Hello and welcome to my next video on carbonyl compounds. These are compounds with the functional group C double bond O. Now these occur if you have a carbon atom and an oxygen atom with double bond. The carbon is slightly positive and the oxygen slightly negative. This because if you look at the bond, if you remember from learning about alkenes in AS, you have a sigma bond and then you have pi bonds, which are kind of like overlapping bonds on the top, and that's what causes the double bond. And there are two you need to know about in particular: aldehydes, which are COO with an H, and ketones, which is COO with just two variable groups either side. You can have aromatic ones, which you remember are ones with in a ring. Oxidation. Now you remember this from AS. If you have a primary alcohol, you can oxidize it to an aldehyde and oxidize it again to a carboxylic acid plus H2, remember, and you use K2CR2O7 and H2SO4 as a catalyst. Secondary alcohols, you have an alcohol, oxidize it to produce a ketone. This should all be very familiar from AS. Now, the difference is reduction. Here you have an H in a bracket which shows reduction, and there's two H for reduction. If you have an aldehyde, reduce it, becomes a primary alcohol. If you have a ketone and reduce it, it becomes a secondary alcohol, and NaBH4 is used. Now that's just very simple, it's just the opposite of oxidation, but it leads to a new mechanism: nucleophilic addition. So what happens is, as we know, the COO bond is slightly positive, slightly negative. Now this slightly positive thing means that an H, in this case an H minus ion, will be attracted to the center. The H minus is a nucleophile. So the H minus goes to the carbon atom, and then the double bond breaks with the bond going to the O minus. This creates, well, you can see what happens next. Then you've got an O minus and the hydrogen's attached. The double bond of the O goes to an H. The bond between H and O goes to the O, which then causes one of the hydrogens to join in with the O, and you've got an OH minus. This causes step 2, the intermediate reacts with a water molecule, and at the end you've got a spare OH minus ion. Now, tests. Quite important to test for these molecules. We use 2,4-DNP and Brady's reagent, which is 2,4-DNP and methanol. A precipitate formed if the COO group is present. Now if this happens, you know you've either got a carboxylic acid, an aldehyde, or a ketone. What if you want to tell which one's which? Aldehyde or ketone? Something called Tollin's reagent. You use this on the chemical. If a silver grey solid forms, it's an aldehyde, nothing if it's a ketone. You now know which. Now we can identify exactly what compound it is. You filter the solution and recrystallize. Now you've got the precipitate formed from 2,4-DNP. That's what you want to filter and recrystallize. Measure and record the melting point, and then you'll get a table and compare. Just a very quick video there. There's not much you need to know on aldehydes and ketones. It's essentially just knowing the group, knowing how to name, and you know how to do that from AS. Oxidation reduction reactions, easy enough. Nucleophilic addition, that's the last mechanism you need to know. Of course, that could be a little bit tricky, but if you just keep practicing, you'll remember it. And the tests for different compounds. So a short video, but I hope that helps with everything you need to know. Thank you for watching, and as usual, leave comments, likes, feedback, whatever. And thank you and goodbye.